This presentation reviews propensity scoring. This brief presentation was organized by Dr. Alemi. The purpose of propensity scoring is to remove confounding in evaluating treatment effectiveness. For example, the purpose of propensity scoring in benchmarking is to remove effect of patient comorbidities in evaluating the effectiveness of clinicians. Thus, propensity scoring allows us to compare clinicians on patients with similar comorbidities. There are 3 steps in propensity scoring. First, you create a regression model that predicts the propensity of patients to participate in treatment. Then you use these propensity scores to balance the data. Balancing data means that you make sure that the treated and untreated patients have the same rate of various comorbidities. Last, in the balanced data, you calculate the impact of treatment. Let us go through these steps in more detail. The first step in propensity scoring is to calculate the propensity of treatment. Logistic regression is used to regress the treatment variable on a set of comorbidities or risk factors. In a previous set of slides, we discussed how a logit function and SQL can be used to accomplish this step. Let us demonstrate these steps through an example with an antidepressant. Here we are examining the effectiveness of antidepressant called Buspirone. We want to know what's the impact of Buspirone on remission of depression symptoms. In this example, taking Buspirone is the treatment variable, and remission is the outcome. In the first step, regression uses the treatment variable, not the outcome. It does not look at the outcome variable. In this regression, the independent variables are various patient characteristics, for example, having a history of heart problems or alcohol use. Patients who receive Buspirone have different illness history than patients who do not. The regression of treatment variable on medical history reveals several factors are significant predictors of receiving Buspirone. These are shown by number of stars next to the row of the data. 8 of the independent variables are significant predictors of treatment with Buspirone. These 8 factors are how treated and untreated patients differ. For example, patients with respiratory illness are more likely to receive this antidepressant. If the patient has history of respiratory illness, the patient is 29% more likely to be treated with Buspirone. In a second step, the data are balanced. There are at least 2 ways to do so: inverse propensity weighting and matching treated and untreated groups based on propensity scores. A common method is to weigh the data by the inverse of the propensity of being in treatment. This formula shows how each patient will be weighted using inverse propensity weights. T is a binary variable indicating if the patient is treated. It is 1 when treated and 0 otherwise. Pi hat is the predicted propensity of the patient. This comes from the regression that we showed earlier. W shows the weight for the patient. This weighting procedure will ensure that treated and untreated patients have the same rate of covariates. So in our example of predicting treatment for Buspirone, this set of weights makes sure that patients treated with Buspirone and those who are untreated with Buspirone do not differ in various patient characteristics, including rate of respiratory illness. If the patient is treated, then T is 1. This makes the second part of the weight structure be 0, and so we are simply weighting by the inverse of propensity for being in treatment group. If the patient is not treated, then T is 0, and we are weighting by 1 minus the propensity of being in treatment. Here we show you in 3 steps how the weight How to weigh the data using R. In the first step, the R code attaches predicted propensity scores to the data frame. This is obtained from previous regression of treatment on patient characteristics. The predicted response from the regression is attached to the data frame. In the second step, the weights are calculated. The if-else command is used to assign separate weights for patients who took Buspirone, those are treated cases, and those who did not, untreated controls. In the last step, a weighted regression of remission rates on various baseline predictors and participation in treatment is carried out. In contrast to when we were calculating propensity scores, the dependent variable is now remission rates and not use of Buspirone. After the tilde, the R code lists the independent variables. Buspirone is now listed as an independent variable, not a dependent variable. Baseline variables are also listed. The last part of the R code tells the computer to use the field called weight in the data frame for the weights in the regression. The regression results are provided here. There is a statistically significant relationship between use of Buspirone and reduction in depression symptoms. The coefficient is minus 0.09, and the probability of observing this coefficient randomly is less than 1 in 1,000. This estimate of effectiveness does not reflect differences in propensity to receive this treatment. These differences were statistically controlled when we weighted the data using inverse propensity scores. The unconfounded impact of Buspirone can be used to compare it to other antidepressants and decide which antidepressant is best for the patient. Also note that several other variables, including variables that were not significant predictors of propensity to take Buspirone, are now significant predictors of remission. Patients who have endocrine conditions, alcohol abuse, opiate use, specific phobias, OCD, bulimia, cocaine use, or various personality disorders are less likely to have symptom remission independent from whether they take Buspirone or they do not. In observational data, remove confounding by weighting the data with inverse propensity of receiving treatment.